In this video, we're going to derive the maximum speed that a car can go when it's making a turn. So basically, we're saying that this car is making a turn that has a radius of r. And we know that this car, it's basically moving in a circle, so we're dealing with circular motion. And we know that the force that causes a car to move in a circle is static friction, right? And so basically what we're going to see is there's a static frictional force that's pointing this way towards the center of the circle that's causing it to move in the circle. And that's the idea. And we're assuming that this car is moving with a constant maximum speed because it just makes our problem as nice to solve, right? We want to make sure our car is moving, like what's the maximum speed? So it's saying it's a constant speed. So basically what we have right here is a back view of the car. So we're looking at the back of the car from this view. And so static friction is going to point this way, right? Now we know other forces acting on the car, right? For instance, the weight of our car and the normal force, right? Right? But what we want to do is we want to find the, pretty much what are the forces, right? What's the net force acting on our car that causes our car to move in a circle? Well, the only force that's causing our car to move in a circle, right, that's acting towards the center of the circle is just our static frictional force. So really, that's all we have. And of course, some of the forces acting on an object that makes the object move in a circle is centripetal force. So we know this is just going to be mv squared over r. So what's static friction going to be? Well, pretty much just say static friction. Well, remember, what we want to find is we want to find the maximum speed that this car can go when it's making this turn. If we're looking for the maximum speed, then we're dealing with the maximum static frictional force, right? We know that static friction is less than or equal to this value, mu s Fm, which means the maximum static frictional force is equal to this value, right? Mu s Fm. And that's the idea. And so since we're finding maximum speed that this car can go, we want maximum static frictional force. And so we want this to be right there. So really, we want this to be right here. Mu s Fn, right, is pretty much what we get from this is mv max squared over r, because it's the maximum speed. Now we know what the normal force is, because we know for this car, like the car's not going to move upward, right? It's not going to move downward. Normal force and the weight force cancel out. So the idea of that we have to know is that the normal force is equal to the weight force. And so that's what we're going to substitute for Fn. We're going to put mg right there. So really we get mv max squared over r is equal to mu s times mg. And so now notice how the mass cancels out on both sides. And so solving for v max, pretty much solving for v max squared first, we get mu s gr. So v max is the square root of mu s gr. And so this right here will be the maximum speed that a car can go when it's making a turn of radius r. And of course, given the coefficient of static friction between the wheels and the road. That's basically what that would be. That's pretty much where this comes from, and that's pretty much it.